to day 19 of calculus. We're going to review for the upcoming test. I'm going to run through a few of the questions on this review sheet. Starting with number 1, and given a function 3x squared minus 1, we're going to use the definition of derivative to find the formula of f prime. So when it says definition of derivative, you are going to have to use the limit definition. So the limit as h goes to 0 of f of a plus h minus f of a all over h. Yes, we have a shortcut, but when it says use the limit definition, you need to use the limit definition, especially when it says show all steps. So we plug in a plus h, and we end up with the limit as h goes to 0 of 3 times a plus h squared minus 1, and then we're subtracting when you just plug in a, so 3a squared minus 1. Be careful of the negative signs. So now what do we end up with? We end up with a negative 1 here, but then we're going to be adding a 1, so those will cancel. So then when you multiply this out, you end up with the limit as h goes to 0 of a times, well sorry, not a, 3 times a squared plus 2ah plus h squared minus 1 minus 3a squared plus 1. So when you distribute this out, you end up with canceling a few things. You have the negative 1 and that, the positive 1, the 3a squared and the negative 3a squared. So you end up with 6ah, this 3 still distributes into both of them. And then you can factor out the h, keep the limit going. So limit as h goes to 0 of h times 6a plus 3h all over h. The h's cancel. And now you can plug in 0 for h and you're left with 6a. This means that the derivative in terms of x is 6x. This tells us the instantaneous rate of change anywhere we want to. So now in the second question it says find the equation of the tangent line when x is equal to negative 2. As we remember, you need point and slope, and we're going to use y minus y1 is equal to m times x minus x1. The point you get by plugging in negative 2 into the original equation. So we do f of negative 2, and that's going to be 3 times negative 2 squared minus 1, which is going to be 3 times 4 minus 1, which is 11. So our point is negative 2, 11. Now our slope is really easy to find because we have the derivative. So we do f prime at negative 2. So we 6 times negative 2 is negative 12. So our slope is going to go into m. And our y value there, x value there. So with y minus 11 is equal to negative 12 times, sorry, that x goes to there, sorry, x minus negative 2. And clean it up a little bit and get y minus 11 is equal to negative 12 times x plus 2. Leave your answer in point slope form. That is totally awesome. So let's find another tangent line, this time with a big polynomial. This we can use the shortcut. If it doesn't say to use the limit definition, you don't need to. So in this case, g prime of x is going to be equal to, remember you drop the power to the front and reduce it by 1. So it's going to be 4 times 3x to the 4 minus 1 minus 2 times 2x to the 2 minus 1 minus 1x to the 1 minus 1 plus 0. The derivative of a constant is 0. So when you do this out, you end up with 12x cubed minus 4x minus 1. Because this is x to the 0, which is 1. So now we know that the derivative is 12x cubed minus 4x minus 1. So again, we need a point and a slope, and the point is happening at x equals negative 2, right there, negative 2. So we need to plug negative 2 into there. And if you do that, you end up with, so you're doing f of negative 2, and that turns out to be 45. So our point is 245. And our slope is what happens when you plug in, sorry, it's not f, it's g, excuse me. G prime of negative 2, and that's when you plug it into g prime. And when you plug that in, you end up with negative 89. So now you just fill in the blanks. So it's going to be y minus y1, which is 45, equals m, so negative 89, times x minus negative 2. So when we actually clean that up, you get y minus 45 equals negative 89 times x plus 2. And again, you can leave this as your final answer right there. Just wanted to point out the hints on these two questions right here. So for this first one, you can rewrite it as f of x is equal to 5 times x to the negative 2. It's the same thing. And then here you can break it into 5 fractions. This is equal to 3x to the 4th over negative 3x cubed plus 2x cubed over negative 3x cubed minus 8x squared over negative 3x cubed plus 4x over negative 3x cubed minus 3 over negative 3x cubed. So you do it as 5 differentiations. So for number 5 here, we're going to sketch the derivative, sketch a derivative. Start with the zeros. Where is the derivative 0? Well, that's where the slope of the tangent line will be 0. It's these highest and lowest points. So at these x values right here, at these x values, you know the derivative has to be 0. So touch the x-axis there. So there's maybe like right about there. So we know at those 3 red points, the function has to be 0, the derivative. Now, if this is the function here, where is it increasing? It's increasing from here to here, and it's increasing from here to here, meaning the derivative has to be positive there. But again, it's 0 back to the x-axis. So if it's increasing, the function is going to be increasing from left to right. So the derivative has to be greater than 0. So in this middle section, it'll go up and then down. And then right here, it's just going to keep on going up. Where is it decreasing? It's decreasing from here to here and from here to here. So on those sections, the derivative needs to be below the x-axis. It's going to look like this. It's going to look like this. So this right here is the derivative function. And the interesting points happen when it's steepest, like right here. It's where it's going to be highest, and right here, it's where it's going to be lowest. But start with the zeros, and the rest should follow pretty nicely. So let's do one more. Where's the derivative 0? What's going to be here and here, because the tangent lines have a slope of 0. Then where is it increasing? It's increasing here and here. So the function has to, the derivative has to be greater than 0 there. And it has to be greater than 0 here. But in between, it's negative, and it'll be steepest right in the middle here. So that means it's going to go down and then up, just like that. So now let's go the opposite direction. This is going to be the derivative function. So what is the function? What could the function look like? So what this means is, let's look again where the derivative is 0. The derivative is 0 in these 3 places, which means that the function has to have a highest or a lowest point when it crosses these x values, a highest or a lowest point. We also know that the function will be increasing here and here, because that's where the derivative is positive. Wherever the derivative is positive, the function has to be going up. It's rising. And then everywhere else, it's going to be falling and falling. So those red values are where it actually crosses the x-axis. So blue is where the function is falling. So it's going to be falling here. And then what will it be doing at that point? It needs to be rising again. So it's falling, then rising. So wherever it crosses this, it's falling, then rising. So it's falling, then rising. So it means that wherever it crosses, it's going to have to do something like this. Falling, then rising. And then it's rising and then falling. So it's going to cross and do something like this. Go up and then down, because the derivative here is 0. It has to be 0. And then falling, then rising. So it's going to go something like this. So if you connect these, you end up with a graph that looks like this. It goes up, down, like that. So again, the function is falling like that, and then the function is rising to here, and then it's falling to there, and then it's rising to there, and it's being told and informed by the derivative function. But start where's the derivative 0? Where it has to be derivative of 0 is right there, because the slope of the tangent line is 0 at these 3 places. This takes a lot of practice, so we will practice it. So this is a graph of the velocity, so the derivative, the velocity of a hot air balloon. So assume positive velocity means rising. So for A, it asks, during what time intervals was the balloon rising? This means the velocity is positive. So the velocity, where is the velocity greater than 0? Well, if this is the velocity graph, it's wherever this graph is greater than 0. So for this one, it's going to be, it's greater than 0 here, and it's greater than 0 there. So what time intervals is that? That's 0 to 8, union with 16 to 24. And when is the velocity greatest? So if this is the velocity, when is it the highest? Well, it's going to be the highest right here, and that's at time equals 4, right there. At what time was the velocity least? That's when it's lowest. That's going to be right here, and that's at 12. So time equals 12. So during what time interval was the balloon's acceleration positive? Acceleration means the rate of change of velocity. The rate of change of velocity. Again, the rate of change of velocity. So this is the slope of the slopes of the tangent lines of the velocity graph. So where is this increasing? Well, its velocity is positive here. It's going up. Its velocity is positive there. It's going up, and there. Everywhere else, the velocity is the rate of change of velocity is negative. So where is that happening? That's happening from 0 to 4 and from 12 all the way to 20. It's not 16, 12 to 20. Then it says, during what time interval was the balloon's acceleration greatest? That means when is the velocity steepest? Where is it steepest going up? It looks like it's steepest right about there. So that's going to be from 12 to 16. These aren't points, these are intervals. Remember, these are intervals. At what time was the balloon at its greatest height? That's such a great question. So it's going up. So it's going up from time equals 0 to 8. So it's going up right here. It's going up from 0 to 8. And then it goes down a bunch, and then it goes up, and then it goes down. So where does it go up the most? Well, it goes up the most here. It goes up from 0 to 8 before it starts turning around. This is a highest point right here. And then it goes down a whole lot. It goes back up here, but not that much. So this is where it's going to be the highest at time equals 8. At what time was the balloon at its lowest height? Well, that's when it goes down the most, and that's all the way, goes down, down, down. From 0 to 16, it's going down. So that's where it's going to be at its lowest point at 16. Time equals 16. So where it's at its lowest. And then it says, explain what the balloon is doing at the points where the graph crosses the horizontal axis. So that's this axis right here, the x-axis. It's switching from going up when it's above to going down. Or it's going down and then up all the way to here, and then it goes down. So this is when it changes from going up to down or down to up. So it's when the balloon changes from going up to down or from going down to up.